All right, today we're going to start Unit 9 looking at complex numbers. So some things we want you to be able to do in this lesson is identify both the real and imaginary parts of a complex number, and then do some simple adding, subtracting, and multiplying of these complex numbers. A complex number, the imaginary number I, okay, I is the variable that math uses to identify the imaginary unit, is defined as the square root of a negative. So if you take square root of -1, we know mathematically we can't take a square root of a negative, but what we're going to identify that as is I. And so anytime you have a square root of a negative, that can be changed into I. And effectively the way we do that is, if you got square root of -1, this negative right here comes out and is changed to the imaginary number, leaving us with just square root of 1, which is 1. So we got 1i, or just I. What that also means, though, is that if you take the number I and square it, you end up with -1. And the reason that would happen is if we were to square both sides here, okay, remember that squaring a square root, those are opposite operations. So the power of 2 and the square root cancels out, leaving us with just -1. So I squared would be equal to -1. You need to know both of those throughout the unit, and they'll be important. When you write a complex number, then a complex number is an expression written with both a real part and an imaginary part if they have both. So whatever this number a is, that would be considered your real part. And whatever this number b is, that's in front of the I, that would be the imaginary part to the complex number. These complex numbers you're going to learn about throughout the chapter. There's a lot of applications, especially in electronics and signals and waves. And so anything if you were to go into anything with electronics or communications, like stuff with cell phones, that kind of stuff, they all have this imaginary unit as part of the math that goes into solving it. All right, so this part wants us to find both the real and imaginary parts of the complex number for both. So for this one, the real part here would be the 6, and the imaginary part here would be the -2, because that's what's in front of the I there. You might just have only real or only imaginary. So with this one, the real part would be 4. There is no imaginary part. If you want, you could think of this as like plus 0i. And so the imaginary part would be nothing. Same with the next one. This one, also there's no I here, so this would be like plus 0i. And so the real part is the 5, 6. D is kind of an interesting one. There's definitely an imaginary part to this one. We can see that I in there. But it's not split into two, the real and imaginary part. It shares this common 5 here as a common denominator. So what you have to do in this case is split this up. So we would say that this is 3/5 minus 2/5 with the imaginary part on there. So both of these get that common denominator as of 5 here. And so on this one, the real part would be the 3/5, and the imaginary part would be the -2/5. Last one here. This one, if you're given this, you need to change it into that imaginary one, because we see we have square root of a negative. And so what happens is that negative part right here, that comes out now, that becomes the imaginary part. So this is equal to now, switch here, this would become I And then now we only have square root of 9. Well, we know square root of 9 is 3. And so we have I times 3. Usually when you write these, they write the number before the I. So this would be 3I. So in this one, it is only imaginary. If you want to think of this as a complex number, it'd be like 0 plus 3I. There's no real part in this one. So in this one, the real part, there is none. It would be 0. The imaginary part would be 3. Okay. So that's a look at that real and imaginary. Here they want us to simplify each of these expressions by adding and subtracting. When you want to add and subtract complex numbers, the goal is to like almost combine like terms. Meaning combine the real parts and combine the imaginary parts. So on this one, the first one here, we got 4 plus a negative 4. Well, that's going to add to 0. Now let's do the same thing with the imaginary parts. We got negative 3 plus positive 3. That means our imaginary parts look like also add to 0. And so the answer to this one would be basically just answer would be 0 because there's no real or imaginary parts. We can just write it as 0. Okay, next one. Again, combine the like terms. So here, what is 3/4 plus 1/4? That would be, remember when you're adding fractions, add the numerator, so that would be 4/4. If we add the imaginary parts, we're adding 1/2 and 3/4. Now there we don't have a common denominator, so we want to get a common denominator. This one we can multiply both top and bottom by 2 and think of it as 2/4. So if we add 2/4 plus 3/4, we'd end up with 5/4 I. That's our imaginary part. And for the final answer then, that first one part we can simplify. 4/4 is the same as 1. So this is how you'd see the answer written. The next one here, these ones are subtraction ones. You got to be a little bit careful on the subtraction ones, just like we talked about earlier in some of the pre-calc lessons. If there's a negative there, you got to make sure it's almost like distributing. That negative needs to go to both parts. So what this one is saying here is we got 5 minus 3I. Minus a negative 2 is going to end up being plus 2. And then this negative and adding there, that's going to make this minus 4I. So now put the like parts together. And we're going to end up with 5 plus 2 is 7 for our real part. And then negative 3 minus 4, that would be minus 7 for our imaginary part. So that would be the answer there. With D, doing the same thing here, that negative needs to get distributed to both. And so this is going to end up being 7I. Minus a negative is plus 3, and then minus an I because we're subtracting a positive here. And then for our final answer, combine the like parts. There is only one real part in this one, just the 3. And so let's write that first, because usually they write the real part first. And then we got 7I minus 1I would be positive 6I. So that would be the solution. There is a way to kind of check these with the calculator. Just going to show you that quick. So for example, if we were just doing that last problem we just did, you can hit 7. I is right above the decimal place on the very bottom. So you got to hit the second button and then the decimal place number, and I shows up there. And then you could put minus, just type the problem in the same, negative 3 plus, and then again we want that I, so hit the second button, our decimal point, because I is above that. Close that parentheses, hit enter, and you get the same answer, 3 plus 6i. All right, now let's look at multiplying and kind of distributing here. So if you have a problem that involves multiplying, then distribute like you would with any multiplication problem. So here, there's one term, in the first parentheses, 2 in the second. We got to distribute, so multiply. Here we'd have negative 15, but there's an I too, so we want to include that. And then if we take 3 times 2, we would get 6. And then we have I times another I, so we would end up with I squared. Now, one thing you got to do when you are multiplying is if there's any power on the I, that needs to be simplified. Anytime I has an exponent, it can be simplified down. So what you got to remember back to is way at the beginning of these notes. Remember that we said I squared is equal to negative 1. And so what we're going to do now is substitute that in place of that I squared. So we have negative 15I plus 6. I squared is the same as negative 1. And so now we do end up with a both real and imaginary part here. This 6 times negative 1 is going to be equal to negative 6. And then we have our minus 15I on there for our imaginary part. So we got a real and an imaginary part in that answer. So that would be the final solution there. If you got 2 terms in each, then you got to go through, and if you want to think that acronym we had of FOIL, go through and multiply first, outside, inside, last here. So 4 times negative 1 is negative 4. 4 times negative 2i is negative 8i. Multiplying the inside ones, 3i times negative 1 is negative 3i. And then if we multiply the last ones, 3 times negative 2 is negative 6. I times I squared is I squared. And so now, if there's any like terms, you can put them together. These middle ones would definitely be some like terms here. That'd be negative 11i. Also, though, we have this I squared over here. So anytime you have I squared, we know we can substitute in negative 1 for that. And so what we have equal to this now is negative 4 minus 11i. But that negative 6 times negative 1, that's going to now be positive 6. Combine the 2 real parts, and we end up with 2 minus 11i. Just to show you that, again, with a calculator one, just as an example here, say we wanted to do this one or check it. You got 4 plus 3, let's do our imaginary part on that one, times negative 1 minus 2. Select our imaginary part again here. And if we hit enter, we should get the same solution we do. All right, last one here. This one, we're going to multiply these 2 things. This is going to come up later. This is an example of something called a conjugate. And a conjugate is what you get when you have the same 2 terms. So like notice there's a negative 6 and a negative 6. There's an I and an I. The only difference between these 2 terms is the symbol in between. And when they're opposites of each other, one's positive, one's negative, that's called a conjugate in math. And conjugates, the reason it has a special name is when we do this problem, you'll see something interesting happens here. So let's do the FOIL and multiply this out just like we did the other one. So negative 6 times negative 6 is positive 36. Negative 6 times negative I is positive 6i. Multiplying those inside ones, we get a negative 6i. And then multiplying the outside stuff, we got a positive times a negative, so that's going to give us a negative. And then I times I is I squared. And what happens here is in conjugates, these middle terms are always going to cancel out because it's going to be the same 2 things, and one's going to be positive, one's going to be negative. So now what we end up with is 36 minus, now we got I squared here. Remember, anytime I has a power, we should be able to simplify it. I squared is equal to negative 1. And so now we got 36 minus a negative 1. Well, we know minus a negative is the same as adding, so this would be an answer of 37. So this is an example of a problem. Even though we're multiplying 2 complex numbers where imaginary parts are part of it, it actually multiplies to a real number. There's no imaginary part to this answer. And so that's something interesting that comes up when you multiply sometimes with imaginary numbers. Okay, you're going to try some of these out now on the assignment, so see how you do.